Alright, so moving back to HackerRank stuff, next one is minimum swaps 2. Minimum number of swaps to sort of given array. Kind of sounds similar to the New Year Chaos one, but let's see what happens. You're given an unordered array consisting of consecutive integers without any duplicates. You're allowed to swap any two elements. Find the minimum number of swaps required to sort the array in ascending order. You're allowed to swap two. Okay? Perform the following steps. Swap 0 and 3. Okay. Swap 0 and 1. Swap 3 and 4. Swap 4 and 5. 5 and 6. Took 5 swaps to sort the array. Complete the function minimum swaps in the editor below. Okay. Interesting. Very interesting. Sample input. First line is the integer n, second line is the integers, or the integers. After swapping 0 and 2, we get that. Swapping 1 and 2, we get this. After swapping 1 and 3. Okay, so we need a minimum number of 3 swaps, sort the array in ascending order. Since we're trying to find the minimum amount of swaps, I don't know if this is like time complexity wise, I don't know if this is going to be as efficient since we're trying to find the minimum. So it looks like what they're doing here, what they're doing with the example arrays, is they're finding number 1, swapping it, and they find number... Oh no, then they didn't. Well, I mean, you could say that they find number 2 and then swap, and then find number 3 and swap it. Minimum number of 3 swaps for this one, so you'd swap 2 and 3. 2 and... Oh, I'm looking at this one. Yeah. So after swapping 2 and 3, which are these ones, you get it after swapping 0 and 1. After swapping 0 and 1, which is this and this, you get it after swapping 0 and 2. So I wonder, what I'm starting to think, what it looks like might be best is if you, whatever the first number you encounter, you swap it and put it in the position in the array where it should live. Array consecutive. Okay, so it is consecutive integers. So I guess we can assume that we have consecutive integers. Swap any two elements, and then we sort it in ascending order. Unordered array of consecutive. Okay, so we could, I guess, in theory, go to position 1. It's supposed to be number 1. If it's not, we swap it. So we would swap for whatever position it should be in. So in this case, we would have, well, let's go here since this one has an, I guess they all have answers. This one, we would go to position 0. It's 2. It's not where it's supposed to be, so we could swap it to next 3, and 1 would come here. That would be 1. Then I guess if the index is where it should be, you can continue. So I'm wondering if you could do this as a recursive function and just keep passing the newer array down and keep going until you hit the very last element, or we know it's sorted. Well, I guess, yeah, you could go until you hit the very last element. That would make it big O of n. That's not wildly inefficient, I guess. Yeah, I guess that'd be pretty good. So you would hit 0. It's 2. It's supposed to be in position or index 1 right here. So you would flip-flop that. So we had 3, 2, 1, 4, 5. Pretty much this. And then we would move on, or I guess since the position where it is now, because you wouldn't be able to exit a function until it's done, right? Let's see. Does that make sense? Yeah. I have to figure out what that all looks like, but I guess I haven't explained this very well yet. I'm thinking you could go through the array one at a time. Whenever you meet an element that is not where it should be, you swap. And then if the swap produces the element that is supposed to be there, you move on. If it doesn't, you swap again. So at most, I guess you could maybe say best case scenario would be, I guess it doesn't necessarily matter, but best case scenario would be you just go through it and it's sorted, minimum swaps is 0. If that's not the case, then you would go, you could just keep swapping until you got them. So yeah, 2 and 3, 2 would go here, 3 would go here. This is not where it's supposed to be, so now we change again. So 3 will go here, 4 would go here. It's not where it's supposed to be. So 4 would go here, 1 would go here. We're done. 2 is where it's supposed to be, 3 is where it's supposed to be, 4 is where it's supposed to be, 5 is where it's supposed to be. So I think that might be a good way of doing it, since we know that they're consecutive. We know that they should have their own place in the index. We more or less just have to push through them all. Yeah. I think that is actually a sorting algorithm. I think it is a name, but I don't remember what exactly it's called. Alright, so let's go ahead and code this up. So minimum swaps, I think what we're going to have to do is a while loop, and we're going to have to keep track of the current index. Oops. And then while current index is less than array length and then at the very end we're going to have to remember to increment so that we will eventually hit that array length. When we hit the first element, what we need to do, and we're also going to have a function called swap, and we'll have to pass in the index and the element. And I'll get that in just a second. In the meantime, we will hit the first index, and then we want to check to see if it is correct. So if let's do an element, the current element is equal to our current index. If element is equal to the current index, so this would say once we hit 0, we would do the first element is this. If the element is equal to the current index, so if 2 is equal to 0, we move on. If 2 is equal to the current index, we move on. Otherwise, so if it's not equal to the current index, we need to swap with the current index and then the element. And then we need to add 1 to the swaps. Then and only then would we exit. So we'll swap it, and then we'll go back to the beginning of the loop and try it again. And so let's say in this example we would have 2. So I need to make some changes with the indices when I swap, because the element and the index are not necessarily the same. So element would have to equal current index plus 1, because we want 1 in index 0, so on and so forth. Yeah. Because we know we're going to start with 1. Can we confirm that in a second? Yes. So it's between 1 and n. So we're fine doing that. This looks ripe for an error, an index error. So the current index has to be less than the array length minus 1. X index, or maybe furthest index is equal to the length of the array minus 1. At the second to last index, everything will have been swapped. So that's our furthest index, is the length of the array. I guess, no, it'd be not minus 2, right? So on this one, the length is 5, but we would stop at this index, which is 3. So we can stop there. So we'll go to the furthest index. If the element is equal to current index plus 1, I think that's correct, because we want it to be in index 0, we want the number 1. In index 1, we want the number 2. So that's correct. Otherwise, we're going to swap. We're going to pass the array. We're going to pass the index that we want to swap, and then the element that is in that index. Okay. So we're going to add one to the swap. So we're going to take since the element's being passed, I guess I don't need to do that. I could just pass the index. Less parameters to worry about. I'll do element at index is equal to array index. And I want the element at, I'll use the full element, wherever lm is. Oop, that's not right. Element. Okay. Element at target index is equal to array element at index plus 1. Is that right? So if the element at index is 2, we want to go to this one, which is -1. Because this is index 1, we want the element 2 to be at index 1. So this is a -1. And we will switch array index is equal to, the element at target index, and the array here, that's not right, is equal to element at index. Those should be swapped. And we'll add swap elements. Let's see. And then we'll add one and continue on. Okay. That would be how you code that out, I believe. At least what I was thinking in my head. Let's see if this actually works. We have... Oh, and then I will need to return a final swaps. So, look at the array. We have the current index. We'll start at the beginning. The second to last index, everything will have been swapped. Will have been swapped or sorted. Then we'll have our swaps. While the current index is less than the furthest index, we won't do anything. I wonder if this needs to be equal to, because I'm thinking of an edge case of an array with 2 elements. Length is 2. Yeah. Length is 2. Right, so let's say it's 2 elements. The input is this. We would want to catch that, swap it, and then be done. So current index would be 0, furthest index would be 0. So we would need to go to that furthest index. We'd see it's 2, we would swap it, and then this would, we'd swap it. The next iteration, if element, which would be 1, is equal to current index plus 1, which would be 0 plus 1 is 1, then you increase that then the current index would be further than the furthest index. We would exit out of the while loop, we would return swaps. Yeah. Otherwise, we're going to swap elements in this array at the current index. So we're going to take the element at the index. So this would, going back up here to the explanation one, I like this example. We would have current index would be 0. So element at index would be 2. Element at target index would be 2 minus 1 is 1. So at number 1, we have 3. So 3 would be element at target index. And then we would change element at index, which is 0, would be 3. And then in this new index, we would have the element at index. We could change this to be target index. Then we would only have to calculate this once. So there's that. We only have to calculate target index once. We shift all those around. Okay. We can probably make that more memory efficient. Let's see. Element at index, and then yeah, whatever. I won't worry about that right now. I don't know. I think this looks pretty good. Let's run it, see what happens. Oh. Oh. Invalid syntax. Oh, I forgot my. That's why. That's too bad. Alright. Sample tests all pass. Let's go ahead and submit it. And all those results passed. So, there we go. There you have it. That's my 40 points and the minimum swaps 2 problem on HackerRank. Thanks for watching.